define a function and it returns.
Hi, Zoom folks. Can someone confirm that you can hear? I guess, oh, there's no chat. Yeah, you can raise your hand. Okay, cool. You can hear. Thank you, thank you, thank you. Okay, let's get started. So nice to see you all. Here we go. Data 8, lecture number 3. Announcements. Homework 1 is due on Wednesday, and you get bonus for submitting it early. So try to get started on that today so you can finish by tomorrow. If you have questions, please come to office hours. This is the incorrect link. But office hours are easy to find because you just go to the course website, data8.org, FA22, and you'll see this big calendar. What do you think's going on with this calendar, Oscar? And we're gonna fix that calendar really soon. Any comments about office hours today? Okay, we're gonna post on Ed with an update about office hours once we know what they are. I hope I'm using the right version of the slides. I guess we'll find out. We'll also offer, in addition to just like drop-in help, which is what office hours are for, some small group tutoring, which is more conceptual, helps you get ready for exams. Now, the best possible way to prepare for exams is to do the work in the course. Do the homework, do the projects, do the lab assignments. That's like how to set yourself up for success. But it's also worth just, reflecting on what you don't understand and talking through new problems. And that you can do in small groups is a pretty effective way to do it. The way the small group tutoring works is that we pair you up with a course tutor and 5 other students and have you meet weekly. So that's an extra hour a week that you could spend. It's not required at all. Yeah, something like a quarter of the students tend to sign up for it, something like that. And we'll release signups later in the week, so you can decide whether you want to participate in that or not. Sorry we don't have an office hours calendar up. It might be that just my internet is broken or something like that, but okay, we'll just get it sorted out shortly after lecture. Other logistical things that are happening or you're wondering about that we can address. It's okay to ask questions. Okay. So let's talk a little bit more about Python. You saw just a glimpse on the first day, but let me just kind of build things up from basics. You know a little bit from lab. This is a programming language that's one of many, but so many people use it that it's not going anywhere anytime soon, because to have a programming language be effective, it has to be well designed, and you have to have a lot of people using it. And that's true of Python, is that it's used a lot in data science. It's also used a lot in general software development. So building, stuff like Instagram or whatever. It's really important that you understand the fundamentals of the programming language. That's what we'll do in this course. We'll try to learn through practice. So I'll show you some examples so you can learn the rules, ask questions if you're not sure how something works. You should actually explore yourself. This is one of the best ways to learn a programming language. It's just to try stuff out. Like there's very little downside if you have a question like, what would happen if I typed this? Just type it in and see what would happen. And if you don't understand why, then ask somebody. And it is important in order to learn a programming language that you write new things that solve new problems, not just kind of copy and paste what somebody else does. It makes you more effective data scientist. So let's take a look together. Python's pretty good at arithmetic. Make that big. Get rid of some stuff we don't need. Add some numbers together. The thing you need to know about programming languages is that they're not very flexible. They don't try to figure out what you meant. Like I can write 2 times 4, but I can't write times 4. Like maybe I want to take that 8 and multiply it by 4. It doesn't work. It's just going to tell you this is not an expression that I understand. So unlike talking to a person that would probably figure out you were trying to do 8 times 4, it just tells you there's an error and leaves it up to you to figure it out. And that's true of programming languages in general, certainly in Python. Also, small changes can have a huge difference in meaning. So, here's something that doesn't work at all. You can't 2 times 4 times 4 because you needed, something else in there, right? So if you write 2 times 4, it's just going to tell you, I don't know how to times and then times again. But if on the other hand, you delete the space between the 2 asterisks, then you get a number. But it's not 2 times 4. 2 times 4 is 8. It's 2 raised to the power of 4. That happens to be how you raise one number to the power of another in Python, is with 2 stars in a row. So this is just facts you need to learn about the language, and everything is very brittle. So if you change it even a little bit, add a space here, then it doesn't work anymore. And that's just a fact of life when you're using programming as a tool. It's a really useful tool, but kind of an annoying tool because it doesn't always do what you want. Okay, what about dividing? We don't use regular mathematical notation. Instead, there are some special rules. So for example, to divide, you use a /, as opposed to like having 8 divided by 9. What's cool is that it does know precedence rules. So this says 2 plus 3 times -5. It's going to multiply 3 times -5 first and then add 2, even though the 2 comes over here. If what you really wanted was to add the 2 and the 3 together and then multiply by -5, then you have to add parentheses, kind of like you would in algebra class. Python doesn't just work with numbers, as we talked about last time. You can also have text, and that text can have spaces in it, as long as those spaces are within the quotation marks. Okay. An expression evaluates to a value. This is an expression, and this is its value. Values can be numbers or strings, and lots of other kinds of things too. We'll see some other in this lecture. The syntax, which is the format of the language, is very rigid. Talked about that. And there's a particular behavior associated with built-in operators that you need to learn. Okay, so here's an interesting thing. I saw that 8 divided by 9 is 0.88888. What about 8 divided by 1? Well, it's not 8, it's 8.0. That's just like some behavior about Python, is that every time you divide, it's going to show you a decimal point. Okay, here's a new topic. Names. Assignment statements look like this. You put a name on the left, an equal sign, and then some expression on the right. That's the name. That's any expression you want. And an assignment statement changes the meaning of the name on the left of the equals. The name is bound to the value of the expression to the right of the equals. Pretty straightforward stuff. Sorry, this keeps popping up and it's kind of annoying. Maybe I'll put it up there. That's nice. A equals 2 means that now there's A. There's no B. Unless I assign B to something. Then I can use B in an expression. A is there. B is there. Notice that multiplying A times B didn't change A or B. It just gave you the result of multiplying A times B. These names don't change unless they appear on the left side of an equals. So if I wanted to capture the result of A times B, I would have to assign it to something else. Now I can keep around that 6. I can even add 1 to the 6. Can't do it backwards. You can't say A times B is result. It's just how Python works. Very rigid. Here's something you can do. If you have A, you could write A equals A plus 1. What's A now? 3. Oh, now it's 4. Now it's 5, 6, 7, 8. However many times I execute this cell tells me however many times I add 1 to A and assign the result to A so that now it's bigger than it was before. Questions about this? Yes. Good question. So what about result, which was A times B? It's still 6 because the names are bound to values. It was bound to 6 before. 6 hasn't changed. A changed, but 6 hasn't changed. It's still 6. So that part's the same. But if I did redo result equals A times B, now I'm going to get 12 times 3 is 36. Huh? Good question. So there are other things you can do, like can I abbreviate this as plus equals? This is like a different thing, but it happens to do the same thing. So now, yes, this is a legal expression in Python. Is this says assign A to the result of whatever it was before plus 1. So now you know a little trick. I would have taught it to you later anyway, but since the question came up, now you know it now. Okay. Why would you ever use names? Well, if I write in a cell like 40 times 52 times 15 is 31,200, and I show this to somebody else, they'll say, wow, 31,200, that's very nice. But if instead I write a notebook with names, it can give meaning to these numbers. So I can say, you know, the California minimum wage is $15 an hour. Assign 15 to California hourly minimum wage. Assign 40 to the number of hours per week and 52 to the number of weeks per year. I guess this person's not taking a lot of vacation. Now, how many hours are there in a year? I could use an assignment statement for that. If I evaluate this, evaluate that, and now hours per year is 2,080. Or I could say like how many dollars do you make in a week? Well, introduce a new name, weekly wages. That's the hours per week times the minimum wage is $600 a week. Or if that's the amount you make in a week and how many weeks are there per year, there's 52, what are your yearly wages? All of a sudden, it's clear what these numbers mean by reading the document because we introduced names and assignment statements to tell us what the numbers were supposed to represent. This is a good way to use the programming language. A function is something that takes in some value called its argument and gives you back or returns another value. This tells you what function to call If there were one called f, you could call it. And this tells you what to call it on the argument to the function. Call f on 27 is how you should read this expression. This says call max on 15 and 27. Max is an actual function. It's built in. It finds you the maximum of all of the values that you pass in. So it would tell you that 27 is the biggest of these two. So let's do some more demos. Absolute value is abbreviated in Python as abs, and it tells you how far something is from 0. -5 is 5 from 0. If you write an expression in here, it will tell you the absolute value of -2, which is the result of 1 minus 3. You can definitely use this with names. So I could say like, oh, the daytime temperature is 52 degrees and the nighttime temperature is colder, 47 degrees. What's the difference in absolute value? We often call that the absolute difference between the nighttime temperature and the daytime temperature. It varied by 5 degrees. I think min is another built-in function that we'll use a lot in data science to find the smallest of these two. And another function that we'll use all the time is called round. So let me tell you about round. If I pass in a number with 3 digits after the decimal place, round will give me the nearest integer. But round is more flexible than that. I could round this to 1 decimal place. Well, I found it. I didn't round it. I round it to 1 decimal place, and it will give me 123.5. This is like super useful for presenting data to somebody. For any function, including round, if you put a question mark after it and then run the cell, useful information will pop up. This says that you can call round on a number, and you can pass in the number of digits that you want after the decimal place as well. And it rounds a number to a given precision in decimal digits. And the return value is an integer if the number of digits is omitted. Oh, okay. The last thing you need to know about functions is that when you call them, I could call them like this, or after I know what the arguments are called, this one's called number, I can put number there. Or likewise, I could put n digits here. Or I could leave number out here and put n digits there. All of these work. What's happening here? This is actually not an assignment statement. This is part of this big call expression, this function call. And it's just an easier way to read it. You know this is the number you're rounding, and you know this is the number of digits, not because you memorized it, because it's right there in the code. So you'll see this commonly in data science, is that people will name the arguments they're passing in, but you have to use the right name. You can't just make up any name you want. It will give you an error. You have to use the name that you saw when you looked up the help. Now it works. Huh? Yeah, that's true. Any function you write here, if you put the question mark after it and you run the cell, you'll get a description of what it does. Huh? Good question. So are you allowed to put spaces in here? Yes, you are. It's quite conventional that you leave out the spaces when you're inside of a call expression and that you put the spaces in when you're just doing an assignment statement. That's kind of how everybody does it, but it doesn't have to be that way. That's right. It does not assign anything. So n digits is not assigned to anything. Instead, it's just telling Python when you call round, use 1 as n digits. But that's kind of redundant, right? Huh? Oh, great question. So if you could put the number here and the n digits here, would it still work? This is an excellent question, but also one that you could just try yourself. So let this be a lesson to all of you. You might wonder like, oh, what would happen? This is a great time to just like explore it. I'll run this one just for kicks. It still works. Okay. Some functions like the square root won't work until you import math. So you'll talk about this in lab this week. There's often a whole block of import statements at the top of a notebook. And all they're doing is allowing you to access features of Python that are built in, but you have to get access to them using this import statement. So import math says, get ready to do some math, and then you can do any kind of math you want, like square root or whatever else is built in. Take cosines, etc. Okay. Kind of ran out of stuff to tell you about functions. Some functions require a particular number of arguments, like abs must be called on one value. Some functions can take as many as you want. So max, it's more flexible. You know, you can take max of 3, 2, and 1, and it will work. You just have to learn that about the function, or you can put the question mark there to look it up. Arguments can be named in the call expression like we saw here, but the names must match the documentation. The question mark gives you its documentation, and now you know how to call function. Huh? Oh, good question, but try it. Yeah. I'm not trying to be a jerk. It's just like good habit to be like, oh, how do I learn this stuff myself? Because there's questions should be bubbling up in your head. Like, what if I put a question mark next to 4 or something like that? And it's a great question, but yeah, I encourage you just to play around and see what happens. Okay, so in data science, the most convenient representation of data that is structured is often a table. A table is a sequence of labeled columns in which each row represents one individual, and the data within a particular column represents an attribute of all the individuals. So, for example, our individuals might be states in the United States. Here we have a label for a column. The column contains an attribute for all of the states. What's an attribute in this case? It's the 2-letter code. Each row represents one state. So we talked last time about running experiments. Oftentimes you have a collection of individuals, you apply a treatment. You need some way to represent all that information. You do it with a table, 1 row per individual. It's possible to represent a table in your computing environment and manipulate it. In order to do that, you have to import data science. This is kind of, I don't know, something I should feel bad about or good about, but when we were building this class, we decided to look up all the different names for all the different modules that exist in Python. And math was taken, you know, ages ago. And so were a whole bunch of other things, but nobody had ever claimed data science. So we just grabbed it for this class. So data science is actually a module that was built for this course. It's very similar to other things that are out there, but it's set up so that you can get going quickly. You can start representing tables and manipulating them without like spending a whole semester in a programming course first. Students have gone off and used it in internships and gotten all kinds of stuff done and great reviews and jobs and stuff like that. So it's fully functional, but it does mostly just exist for teaching this course. And this course is offered in many universities, so there's lots of people that use it. but it's not really designed for huge data analyses that happen in industrial settings. It's designed for learning. And yeah, we tried to set it up so that the expressions that you write using data science are easy to read. So this says, read a table from a file called cones.csv. CSV is an acronym for comma separated values, and it's a standard way to use text to represent tables. And here we're reading in that table and then assigning the whole table a name. Oh, my goodness. Don't watch what I'm doing while I fix this disaster. That's very unexpected. Copy. You people are probably wondering, like, what is happening in this course? The calendar doesn't work. The demos don't work. But now they do. Okay, back in business. So all that happened right there is that there's a file. I'll show it to you because we've gotten this far together. There's just a file that's got some text in it. And you can see this is a table. It's got labels. It's got like values for different attributes of some fictitious ice cream. And the file was in the wrong place. So that's why it didn't work. But now I put it in the right place. So now it works fine. Question. Say it again. Why is this word table capitalized? That's just how the data science module is designed. Okay, once you have a table, you can do things like look at particular columns and particular rows. And that's something that we'll focus on quite a bit in this course, is how you manipulate a table. Because typically you have some data, but you want a different version of it. And that involves picking out particular columns, sorting it, getting the data that you want from the data that you have. And the programming language Python is good at doing that. Very flexible, but you have to learn all the commands and how to chain them together. So that's kind of the goal for the next, this week, I would say, is learning how to take a table and manipulate it a little bit in order to learn interesting things about the data that are represented by the table. So what are some things we can do? We can just look at the beginning of the table. Show shows you the first 3 rows. The other 3 rows are still there, they're just not shown. You could select a particular column. So the idea here is that there's some strawberry that's pink and it's $3.55. But maybe I don't care about the color and the price, so I could just select a particular column. What's interesting is how this expression is built. You say what table you're selecting from. The dot indicates what action you're going to perform. Like, what are you going to do with the table? You're going to select particular columns. Why not rows? Well, that's something about select. Select always picks out columns. This is true in data science. This is a standard convention across table manipulation and computer science in general. A standard thing you can do with a table is select particular columns. And then, just like any function call, you're going to write down what you want to select. And here we put quotes around the flavor, because quote flavor is the word flavor, the label flavor. But if instead I had just written flavor without the quotes, it would try to figure out what flavor was assigned to, and it's not defined because we never wrote flavor equals anything anywhere. So one way to think about whether you need these quotes or not is like, is this something that was already defined earlier, or is this just data? Is this just a word that select knows what to do with? And in this case, it's the second one. Flavor is a word that select knows what to do with. It's going to compare it to all the labels in the table and find the flavor one and show you the values there. Yeah. Well, what's the difference between using double quotes and single quotes? Is nothing at all. The only difference, seriously? What did I do? Got me excited. The only difference is that you can put apostrophes in the double quoted. Cool. And it's fine. But if you were using single quotes, this wouldn't work because it would think this was the end and it would crash. That's why there's double quotes and single quotes in case you want to put apostrophes in there. Yeah. This looks a little bit different from our former import statement. When you import this way, you always have to say, get something from math. But here we didn't say get table from data science. We just said table directly. When you write your import statement this way, you get to refer to everything directly instead of having to put data science dot before it. And this star just means everything in data science. Uh-oh, we got problems. Okay, so if you're following along, you're gonna have to go back to the website and click on the demos, and then everything should work. And if it doesn't, sorry. And I know I just did some magic, don't worry about it. I'm just trying to set it up so that it works for people following along. Okay. What else might you want to do with the table? You might want to get rid of a particular column. The drop method does that. Everything but the flavor is cones.drop flavor. Now, remember when I said if you set a equal to 2, then you can compute a plus 1, and it will tell you a plus 1 is 3, but it didn't change a? Well, likewise, if I write cones.drop flavor, then it will show me what I get when I drop the flavor, but it didn't change cones. Because I never said cones equals something new. So cones was still the whole table. I just built a simpler version of it by dropping the flavor. But if I really wanted to drop that flavor permanently, then I'd have to write like, well, I kind of don't want to drop the flavor. Let's drop the price. Let's say money is no object to me. So I'll build cones.drop price, and then I'll set cones to that. This is saying every time I use cones from now on, there will be no more prices. Because who cares about that? There's not like a way to get it back unless I go all the way back up here and read the table again from the file. So you do have to be careful when you reassign your name for the table to some simpler version. But when you do it, then you can do something else next if you want it. A better way to do it, the more common way, is that we'll start with the whole table. So here we are. We have all of our cones. Instead of using the name cones again, we could say cones without prices. So now we can refer to all the cone data that we had originally, and we can also refer to the version without prices, depending on which name we use. That's a good way to organize. You got to stay organized when you're programming. This is a good way to organize things, is that you want to like build a new result that's more useful than the last one. In this case, we got rid of the prices. Give it a name, but don't reuse your name that you already used or you'll lose track of what you had before. Does that make sense? So we learned about select, we learned about drop. Now we're going to learn about where. We're going to spend a lot of time on where, but today we'll do the simple version. Where the flavor is chocolate only gives me the rows where the flavor is chocolate. Now, I didn't change the table. They're all still there. It's just this version of it is where we only have chocolate. And so we could also look at the ones that are only strawberry. The last thing I'd like you to know about is sort. If I sort by the price, I'll get the rows that are all the original rows. It's just now they're sorted by price. It's important to know that you're sorting not just the prices themselves, but the whole rows. So once upon a time, there was the dark chocolate that was $5.25, and there's still dark chocolate that was $5.25. It's not like we've mixed together the strawberry price with the chocolate flavor. Instead, we've just reordered the rows. That's what sort does. So select and drop are about picking particular columns. Sort and where are about doing something with the rows. In the back. Oh, great question. You know, we not only don't care about price, we want to buy the most expensive ice cream because we can. So how will we do that? Well, you can sort by price and then add a second argument, descending equals true. I'll give you the most expensive ones at the top. Yeah. Good question. So the question is about what if a value is missing? Like I have all this data, but I don't actually know the price for one of the rows. What would happen? We're not going to deal with that case in this course because it's hard to know what to do. If you want to like come up with the average price, but you only know some of them, then there's no like way to guess the missing one perfectly, right? Except for to go look it up. So in this course, we'll always have values there. But this is definitely something that shows up in real world settings where you have incomplete data. And there's many different techniques for trying to fill it in. Once it's filled in, then you can apply everything that we do in Data 8. Huh? Good question. So I may have deleted this, but let me just bring it back. Yeah, so once upon a time, this was like that. This said two things. This said, build me a table that just looks like cones, except for there's no price column. And this part says, now assign cones to that new table. So without the equals, you would build it, but it wouldn't change the cones table. With the equals, you not only build it, but you also change what the word cones means so that when I run to this next line, there's no prices anymore in the cones. This one has to be here. Otherwise, it doesn't know what it's dropping. I'll just tell you, I don't know how to drop unless you tell me what I'm dropping. Good questions. Let's see if we can get our table back. Phew. Other questions? Yeah. Oh, good question. You have cones and you sort by a column using that's filled with text, that's filled with strings. And I'll just give it to you in alphabetical order. And that can be useful. All right, let's see what we learned. We learned that select constructs a new table with just the specified columns. You can actually select multiple columns. I don't think I showed you that. But here's cones. If I select both the flavor and the price, because I don't care whether it's dark chocolate or light chocolate, then I'll end up with a 2-column table. The same one I'd get if I dropped the color. Drop constructs a new table in which the specified columns are omitted. Sort constructs a new table with the rows sorted by the specified column, and where you come up with a label and then you come up with a value, and it constructs a new table with just the rows that match that value. And you might wonder, like, oh, can I get the rows that are bigger than something or smaller than something? We will do that, but not today. The question is there some way to find all the rows that don't have chocolate? Because we had a way of getting all the rows that do have chocolate. Can we get all the ones that don't have chocolate? And if I could spell, then the answer would be Well, I was going to try to show you a trick, but I don't actually remember how exclude works. There is an answer, which is that you can give a condition here that says it's not chocolate. But I didn't tell you about all that yet because it's for a future lecture. But I'll give you a little preview because you're going to see it soon enough. You could say this is R not equal to chocolate, and you'd get exactly what you want. Except I gotta get the parentheses right. Oh, there they go. So actually, where is pretty flexible. You can say like, is something bigger than or less than or not equal to, and all those things are useful. But for now, just focus on, when can we get something that's chocolate? Okay. This is a really boring table full of data that I made up. Yeah, question. Can you draw a diagram? Oh, great question. So could you draw some data visualization using this table? Like, could you draw a histogram of the prices or a bar chart or something like that? Yes, 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 and yes. So once you have a table, you can visualize it using any of the standard methods, and we'll go through all that pretty soon. Yeah. Oh, so there's a question about, like, if you want to say a where it's either strawberry or chocolate, how do you do that? There's a way, but it's pretty long. So maybe we'll do the lecture where we talk about all the different ways of doing where, and I promise we'll get there pretty soon. Okay, cool. Let's look at a more interesting table. So I'm worried that this isn't copied over. Oh gosh, what have I done? We're gonna do the same hack as we did before. We're gonna go find it. More missing data. Okay. It's for the folks following along at home. I looked to see if this was updated. It wasn't. So we can get a table of all the NBA players' salaries up through the 2020 season. I got the wrong one. Up through the 2020 season. Oh yeah, there we go. So we can have the salaries from like 2000 and stuff like that, but it didn't have 2021. Nobody's updated the data yet, and I didn't have time to do it. So this was actually just like some random person on the web, as part of a personal project, decided to collect all the salaries of all the NBA players and put it into one of these comma separated values. And you can go to this link and check it out. I don't actually know why they did this, but good for them. So these are all the players in the NBA, 2000, 2001, 2002, etc. It's actually quite a bit of data. And so when you load this table, by default, we're only going to see the first 10 rows, but then it will tell you that there's 9,446 other rows that are there. They're just omitted from the way we're displaying it. And this is equivalent to saying NBA.show 10. If we wanted to see more than 10, we could put 12 in here. I don't want to get too crazy. We could even do 15. Okay, so and we see that way back in 2000, when I was around watching the NBA, and I'm not sure you were alive, Shaquille O'Neal was the highest paid player in the league. So let's see if we can find something more relevant to today. If I say NBA, where the season is 2020, now I have fewer rows. Only the 10 I see here plus 518 more is 528. Steph Curry was the highest paid player in 2020 season. After I have a table of just 2020 salaries, I could narrow it down further if I wanted by taking that table and just, for example, selecting all the players that play point guard. Now I have an even shorter list. 10 plus 72 is the 82 point guards on NBA teams in the 2020 season. Now that I've done all this work, I could give this smaller table a name, because remember, NBA hasn't changed. It's still got all 9,456 rows in it. But this simpler version, where it's only in the 2020 season and where the position is point guard, now has a name, point guards, which is a name that I made up, but it seems like a reasonable name, and it's only got 82 rows in it. Pause there for a second, see if there's questions about the data, about the code, about what's going on. Yeah. Oh, the question is, how come this doesn't have quotes around it? That's a fact about the data, is that when you load in a data table where the whole column is full of numbers, then it just treats them as numbers as opposed to text. Huh? Oh, good question. So could you keep on stacking dot wheres in order to get even more narrow? You could, because this is just another table. Instead of the NBA table, it's the NBA where the season is 2020 and the position is point guard. And if I really wanted to know, oh, I only care about my favorite team. You have a favorite team? Oh, the Celtics? Pretend I didn't hear that. Okay. Where the team is the Warriors. Okay. Then we'll find the highest paid point guard and the 522nd highest paid point guard. This rank is actually part of the data. This was in the original table. And so to figure out what it means, we'd have to go back and look at the original table. This is the 522nd highest paid player in the whole league, not just the point guard position, not just on the Golden State Warriors, among the 2020 players. That's where the rank was. Oh, I can tell I made a lot of people mad by dissing the Celtics, which are a wonderful team. All teams are equal. Okay, question. Oh, this is a great question. This is a great question. Hold on. We're almost done. If you've now stacked all these wheres, could you stack other stuff on top too? Like, could you now select the salary? And the answer is yes. So you can keep narrowing down the table, sorting it, picking out which rows you want, which columns you want, until you have just the data you need. And then you found something interesting about the world. Okay, let's call it a day there, and I'll see you on Wednesday. And the office hours calendar works. So come tomorrow, 12 to 5 in Warren Hall. See you there.